I hope everyone had a healthy lunch break. It's always a little bit of a challenge to be in the first session post-lunch. So I hope we can do enough justice, to keep the energies awake in the entire session hall here. My name is Alek Tiwari. I am a partner with KPMG Consulting Practice. The session that we are going to talk about today is focused around edge computing. To give you a background on what we are going to cover in the session, data center is one of the space which is very hot space for India. We are seeing a lot of growth momentum. Arguably, India would be in a place where we can almost call it like the data center decade, right, for the country. In terms of growth numbers, if I talk about the data center space in India, we are looking at a growth of more than 15% year on year over the last several years. India today has, just to give you a little bit perspective on numbers, India today will have close to 500 megawatt approximately capacity of data centers, and it's expected to touch more than 1.5 gigawatt in the next 5 years. If you look at the plan of the various players who are setting up capacities, and if you count their individual plans, it will probably cross 2 gigawatt. The only country which comes in the range of these numbers is US. US today, the capacity would be around 2.5 gigawatts, right? So India is already around 1/5 or 1/4 of the capacity. And if you look at the growth plan, in 5-6 years, it will probably be very close to catching up with US. Even today, another metric, if you look at megawatt per capita consumption, right, it's very, very low for India. So there is a huge opportunity for data center growth. It's also driven a lot because of the factors like 5G, right? Factors like IoT, Industry 4.0 booming up, factors like adoption of cloud, right? More and more people looking at adopting cloud, which will need a lot of infrastructure, IT infrastructure to support cloud. So that's where data center journey is a growth journey. It's close to a $5 billion market today, and it's expected to again double in the next 3 to 4 years in India. One of the important sub-growth areas in data center is edge computing, right? What we call as edge computing. That's essentially a smaller setup for data center, but driving slightly different needs or slightly different specific use cases. And we are going to talk about edge and beyond. So that's the theme today of the panel. I'm joined in by eminent panelists here from different organizations, thought leaders in different and specialists in different domains within data center, edge, cloud computing, infra, AI, those cases. So we'll start, and maybe as we go through, we will also have specific questions to the panelists, and that is the time I'll request the panelists to also introduce themselves. We will have around 30 to 40 minutes panel discussion, and after that we'll open it up for Q&A to everybody present in the hall. So to begin with, let's try to understand what is edge, right? We have all heard about data center, we have heard about the hyperscalers, and now there is this term edge. And within edge also there are more terms like far edge, near edge, deep edge. So I'll request Piyush, if you may want to just talk about what is edge computing really mean, what are the various versions of edge, and what is there to what is basically driving the demand for edge computing in the country.
I hope I'm audible. Yeah. So good afternoon, everyone. I'm Piyush Sinha from Red Hat. So I take care of technical sales for India and South Asia for a vertical called Telco, Media and Entertainment in Red Hat. So yeah, so what is edge? Just before this panel, I was talking to one of the panelists, right? So he was telling me that 5 years ago also we were talking about edge, and people, and I think today also when I talk about edge, I will be talking exactly the same thing. So what has changed in the edge, right? So first of all, we all need to understand what is edge. Edge, when we say, it's a place in the network which is close to the user. When I say user, it can be a device, it can be an enterprise, it can be a human being, it can be a computer. Whoever uses the, consumes the service. So that's the user. Anything which is closer to the user, which is the access layer, is what edge is. Now, we need to understand what was the whole purpose of edge computing, right? So any technology, when it is required, so there are only two reasons why technology is required. It addresses two things. Number one, that there is a business problem for which you don't have a proper solution, right? And that's why you want evolution in the technology or technology enhancements to solve that business problem. I'll come to what that business problem was. The number two is that there are opportunities which you want to capitalize upon, the business opportunities. But since you don't have the right kind of technology, you are not able to capitalize on those opportunities. So what was the pain point and what was the opportunity which Edge claims to address? The pain point was that as the IP and data evolution happened, we started producing lot and lot of data, hell lot of data, gigabits, terabits, and all that of data. But that data needs to be processed to make some decisions, to make sense out of it. But what used to happen? We had a processing which is happening centrally. So that data has to travel all the way to the central location for processing and the decision making so that the action can be taken. It used to introduce two problems. Number one, it required a transport all the way from the access layer to the central layer, which is a very costly affair. It's a big cost for every service provider. It used to choke the bandwidth because if that data has to transfer from all the way from the access to the central location, it will choke the bandwidth as well. So it will create some bandwidth constraints. And at the same time, since the distance was long, it kind of used to introduce delays in terms of the latencies. The kind of quality and experience you want for some of the applications which are latency hungry, you would not get it. So that is the problem which Edge tries to solve. That's the business problem I'm talking about. The second thing is, which is the business opportunity. So there are a lot of use cases. We all know AR, VR. We have been hearing about it for a very long time. We have been talking about cloud gaming and all that stuff. So these kind of applications, if we talk about AR, VR, they require both enhanced mobile broadband kind of data as well as they require kind of latency and processing. At the same time, if I talk about cloud gaming, that is a very latency hungry application. Any cloud gamer, if you don't get the right kind of latency, your experience will be bad. You can lose the game, you can lose the money if you are in a professional cloud gaming kind of a thing. So these are the opportunities which were there for a very long time, but we did not have the right kind of technology to address those kind of business opportunities. So all the use cases today are for today and for future. It will be all based on these kind of things. EMBB, MMTC, URLLC, these are the pillars. Now, I see with this 5G impetus, this edge will be expedited further because what 5G does, 5G brings you low latency, 5G helps you for enhanced mobile broadband, 5G helps with you MMTC kind of cases where you can address millions of devices which could not be addressed in the 4G. So with 5G coming in, and then 5G also brings in two more important things, I must tell you. One is decentralization of core, where more and more of user plane functions are moving towards the edge. And number two, centralization of the radio, where your DU and CU, where you are bifurcating the radio, where digital distribution unit and the central unit are moving towards the center. Those computes would also now be sitting at the edge or near edge somewhere, and those computes can then be shared by all the other applications as well, which was the problem for the edge earlier, because if you want to have just edge for some application, it was not very efficient. Now the core architecture, the radio architecture also is kind of going so much that there are a lot of edge compute which would be available. For example, far edge, which will be used by all the RAN workloads. So those edge locations can also be. So I think with this 5G technology, with edge computing, the use cases, opportunities, and pinpoints, we are at a very unique intersection point where I see that edge is going to, go further and further, and we will see a lot of edge use cases coming. Thank you.
Thanks, Piyush. So clearly, I think you were saying the technology was, the use cases were there, but we didn't have the right technology to drive the adoption of edge. 5G is one of the big use cases. OTT consumption, video, you talk about gaming, that's another big use case. 5G now, obviously, telcos have launched 5G in the country. I've been talking to some of the telcos myself, and they were talking about, just to give you a sense of numbers, they were talking about setting up 1,000 edge data centers across the country, one of the big telcos. Uh, I've also been talking to some of the independent data center providers, and they are also talking about in the volume of setting 20, 30, 40 edge locations across the country. So what we see that the 5G networks and edge computing can possibly drive a lot of synergy with each other. We have Vidya Ratan joining us from Airtel. So Vidya, if you could help us, throw some light on what is the synergy that you see between 5G and Airtel has launched 5G. So what do you see the synergy between 5G driving the, the adoption of edge networks across the country, edge data centers across the country? How does Airtel is looking at this opportunity currently? What are your plans around edge?
Hi, my name is Vidyarthan Shukla and from Airtel. So just like Piyush explained the use cases around EMBB and ultra low latency. So I will try to give some practical example. If I take example of connected cars. So connected car is giving 5 petabyte of data, sorry, 5 terabyte of data per day. So if we need to process that data, crunch that data, take some decision on that data, and sending it to some central site where the crunching and analysis on data is happening, then it gives, suppose you are driving a car and you need to take some left or right turn, and it goes to the central, and then you get a decision, okay, left or right, till the time it is gone. So latency is very, very important in this, where we want, so your data processing is happening at the edge side. So this gives an opportunity that besides connectivity, how you can build a complete solution around it. So I think this is what we are focusing, that connectivity is one aspect. With that connectivity, what solutions, what maybe innovative ideas, or what problem we can solve with that connectivity and edge together from cloud perspective also. Another example, like very practical, if you download a game on your mobile, so I would say that that is taking around 2 to 3 GB or 5 GB of space in your mobile handset. But assume that if all that data is going to the central and then you are playing that game, it is practically impossible. So only the data points which need to be synced to the central side, that is sent from a control perspective, and that's how you get a good user experience. So from user experience point of view, there are a number of cases which we can talk about. Conceptually, I would say that there are 4 scenarios: that data is produced locally, consumed locally. That is one. Data is produced locally, consumed globally, or produced globally, consumed locally, and produced globally and consumed globally. So within these 4 scenarios, we can build that from edge perspective, what problem we are going to solve.
Jump in. Check. Hey, my name is Maneeb and I'm from Intel, right? So I heard both Piyush and I think Vidya aspects of it. And I wanted to kind of also give a perspective of what enterprises are thinking, right? So as you build infrastructure and network, where's the pull for this coming from? It's almost, I know we're all, hopefully we're not wearing masks anymore, right? So we're through COVID. But through COVID, there's a lot of retailers, manufacturers who had to suddenly implement socially distanced, self-service checkouts. Manufacturers, there was less people coming into the factory floors. So the pull from the enterprises has been about how do I stop, fraud detection or theft at the self-service checkouts. So I had a US-based retailer who does DIY. Think about building things yourself. 2,400 stores across the United States. As they implemented these self-service checkouts, their annual loss, back to Piyush outcomes, from the front of the store, from the self-service checkouts, was about $1 billion a year. Right? So it's implemented. Now they had to implement it because of social distancing. Now they have an issue. because how do I, save $1 billion loss? And these retail stores operate at very thin margins. So they are very, interested in edge computing, right? So how do I do stick cameras? Cameras generate a lot of traffic, like you just said. So this is data locally consumed, your example, and locally used, because how do you infer that? Second, manufacturing automation. All of these have been around for a while. It just didn't happen, but manufacturing globally, we had the most 43% reduction in workforce during COVID, right? And we had all the supply chain issues. So they also accelerated a lot of automation. So if you look at these segments, what is pulling this suddenly was like almost a post-COVID phenomenon. I just wanted to add that lens. So as we build out the networks, you also have to be very careful on use cases, points of consumption, industry verticals where this is happening, right? So there's a massive pull, which wasn't there in the past, right? So it's like, hey, almost, I'm impressed with UPI, digitization, transaction. But that also was forced through a motion of COVID, right? So I think it's and this has been nice to have pre-COVID, but post-COVID it's become a must-have.
Thanks, Munib. Thanks for chiming in. So going further, a little bit further on the use cases, because I think that's an important point from a business perspective, right? What is the relevance of edge and what could possibly be picked up? What could be the killer use cases? In fact, yesterday we had 2 or 3 sessions here only at the IMC, which was just focused around 5G killer use cases. We always talk about killer use cases. So we have Ludwig joining in us as well, and Ludwig, you're coming in from Singapore, right? And Ludwig leads a multi-million-dollar business at Ericsson. So Ludwig, if you could throw us some light, and must be working on 5G with various telcos and looking at 5G adoption across various countries, India being one of them, and maybe other countries as well. How do you see 5G in India being a little different than others? Is India in the same pace? Because India has, in many places, especially in telco, has actually leapfrogged the technology as compared to many other countries. But the 5G is just launched a few months back. So as compared to other countries, do you see any specific killer use cases, right? Or other use cases, telco-driven use cases or 5G-driven use cases, which largely utilize more of edge, right? Which you think could be relevant, maybe relevant for India or may not be relevant, but do you see any global emergence of good use cases around 5G leveraging edge?
Yeah, thanks for the question, and really exciting to be here in India, where I think it's really happening. So I'm based out of Singapore. I run our cloud division for Asia Pacific, South Asia Pacific. I've got a relatively large team, so we're 3,000 people, and the majority is here in India. And I can tell you, we've been super busy building 5G networks here in India for our customers. We're really honored to be deploying them here in India with our customers and our partners. It's absolutely amazing what India has done, this 1 year. In 11 months, gone from 0 5G users to 100 million, and we're gonna add another 30 million this year alone. No other country has the speed. And why do I think this is exciting? So I don't know about you, but when I was a kid, I always wanted to be born 50 years in the future. I'm born in the 70s, black and white TVs. The phone was connected to the wall. It didn't even have buttons, it had this, dial thing, right? Now, we live in a 5G era. India has just put rovers on the moon, on the backside of the moon. Elon Musk is gonna send people to Mars by 2030. We've got self-driving cars that are starting to come. And we've got these pretty cool devices which we can connect anywhere in the world. So pretty much is happening now. But talking about use case, something that really hasn't happened is utilizing the full potential of what these networks can deliver. But if you look at the speed that India has, you look at the partnership that we see with universities, it's gonna blossom like crazy. And why do I say that? Because the networks that are being built now are more than a communications network. before you could do SMS and voice and you could do data, but the networks that are built today are really platforms of innovation. They're platforms of innovation. So why do I say that? Because now with the networks today, you can slice them and you can dice them into different type of characteristics for the use case that's needed. And why is that important? And I'll use one example of a use case, which actually Airtel has been working at. You did a partnership with Apollo Hospitals and launched use cases for healthcare, which is quite important. So when you slice a network, and you need edge for that, because you're going to do compute in the edge. And why do you slice it? Because you want to ensure that you have a secure channel. Nothing happens with that. You want low latency, and you can't give low latency to everyone. There's not enough spectrum for that. So you can give it to a few. So one use case is a use case that we've been working in the healthcare industry for some time. It's called a haptic glove. You know what that is? Haptic glove. Anyone tried? Haptic is like, it buzzes, but it actually doesn't move. So in ambulances, we're putting these haptic gloves. Because if something happens to you, you want to get to the hospital pretty quick. But it's not always so easy to get there quick because there's traffic. And it takes time to get there. So what you want to make sure is that once you reach the hospital, all of the investigation is done so they can do what they need to do on you. But it's hard to put doctors in every ambulance. It's impossible. So with a haptic glove instead, you can put this on, and then that works like a remote. So the doctor's actually sitting, whatever location, could even be working from home, but still control that glove in the ambulance. Doing the example that we're working with the healthcare industry on is doing ultraviolet scan, so that you know where the injury is, and to do that, it's relatively simple in terms of the glove, but you need to ensure that communication channel is pretty secure, pretty low latency when you need edge data centers for that. And then once you reach the hospital, they know exactly what to do for you. And that's just one example of how this platform, this network, that you now for the first time can slice. So remember, in 4G and 3G, 2G, all of that, it was very cumbersome to slice the network. But in 5G, you can do that. So that means that it's a huge opportunity for the industry to start to leverage the capabilities of the 5G network for any use case. And this one with the haptic glove and the ambulance is just one. So it's pretty exciting. So if you're young, you don't have to be born 50 years in the future. Actually, it's happening for all of us right now.
Thanks, Ludwig. Thanks a lot. See, another segment from a use case or from a customer segment perspective. So telcos, of course, there are bunch of use cases which are driven through the telcos, whether we call it the example that you mentioned, which is around maybe medicine or healthcare side. There are use cases that you mentioned on connected cars and other telco use cases. But edge is also something like Piyush had mentioned, is closer to the consumer, right? So which means traditionally if the large data centers are set up in Delhi, Bombay still is like 50% of the capacity, or Bangalore, Hyderabad, Chennai, edge is expected to be many more and closer to the customer, so more in tier 2 towns or more in other tier 1 towns. So there is also an understanding that because, and India is very well spread out, right? Organizations are also spread out, and there are so many SMEs. India has close to 60 million MSMEs, right, which are registered. 60 million MSMEs, even around 6 million are actually registered MSMEs, GST registered MSMEs. So that's a pretty big number. Many of them will have IT requirements. They will have infrastructure. Many of them will actually maybe using infrastructure on premise today, right? Or some of them would be actually now migrating to cloud. So there's an understanding that would edge, because it's also closer to the customer, help them move their on-premise infrastructure to the edge data center, and how could actually edge help MSMEs and help organizations in smaller countries leverage the power of cloud. Right? The large organizations today, most of them are on cloud, most of them are with the hyperscalers. But with smaller organizations who still don't have the ecosystem to maybe connect with them, get them on the cloud, they may also be having concerns around how far their data is going to reside, whether it is accessible to them from a manageability perspective. So does Edge open up opportunities for SME? And maybe Vivekji, if you could try to give us a perspective, as you're from BSNL, you will have the biggest network in all of those towns and ecosystems. So where do you see the opportunity of Edge for SMEs?
Yeah. Good afternoon, everyone. I am Vivek Banjal. I am on the board of BSNL looking after the cloud data center business and the fixed line business. So if I were to name the title of today's session, I wouldn't have put it age and beyond. I would have put it age and comeback. Now, why I say comeback? My friend has already told you that when he was born, there were dial-up phones and those things. So that time, a telephone was used for calling someone within the city, within the town. There was no STDs. There were trunk calls which used to be booked. So 90% of the people's requirement for the voice was completed within the town. So you had an exchange which is connecting all the people in the town, whosoever has the telephone number, they'll talk to each other. So it's very well travelable, but you can't travel to everyone's home, 5 times in a day. Then, we have evolved to STDs, and then this world is a global village, and everything is a circle. So our Mother Earth is also a circle. Now with this consumption of the data, where data is generated from the same place and consumed at the same place, as Vidya told that one of the sector is produced and consumed locally. So we are back to those data exchanges, which are now called with a fancy name like Edge, where you need to be, talk to data within the town. No need to go beyond the geography. This in a very simpler term, what the age means. So I'll say age and come back. Only thing is, we were voice driven, now we are all data driven. So there is none of, need to go beyond. Connected car is a use case which I am seeing for last 2015, MWC Barcelona, I had seen connected cars. And Google also had tried then regulations and those, stopped. But I still see a very simple use case. We all have waited on traffic signals at a red light. And every time frustrated that there is no one passing through, but the clock is showing 35 seconds, you have to wait for 35 seconds. So why can't somebody can read that at what signal, how many cars are pending, so that 35 can be reduced to 5 if there is no traffic on the other side and we can be allowed to go through. That's a very simple use case, which actually needs the age, because you have to read through and then just change the clock and turn the signal red to green or vice versa. That is something which is very easily possible. And why this requirement has come up is because the data consumption for a fixed line, because I have a domain of fixed line, is more than 200 GB per user, even in a village. Right now, I have 500,000 customers who are actually using the data in the panchayats and down below villages, provided by a BharatNet initiative of Government of India. And I am seeing that if he is consuming 200 GB of data in a village, so what kind of volume blast will be required if you say that tier 1, tier 2 town, you have edge centers. I have more than 700 plus district places, 5,000 plus blocks which are next to district going towards the village, and I have 27,000 my own exchange locations. So other than the gaming and the OTT, where you need very low latency, real-time thing, there are a lot of use cases for MSMEs where they need to make sure, only thing is the ecosystem which the fantastic startups which are there in India and around should start looking into it as an application for MSME, as we have millions of them and they are not very big, so they don't have the even mindset of demanding something. But if an opportunity is presented, it will be grabbed by both hands by all those MSMEs. And as a telcos, we are the enabler, because even for an edge data center, what you need is a data environment along with a robust, uninterrupted 24/7 connectivity. Then only it is worth the use. So nobody better than telcos can enable all those fantastic applications and meeting of the demands of my retail customers, MSMEs, small, big, home user, everyone. So there I see that the application for those industries where they can be enabled for better profitability, better productivity, because the number is very large. So a proper application will be very useful, very handy, which the startups should look at it. And as an enabler, we already have such a strong presence. And it was rightly pointed out initially that, telcos have been more immersed in their own data center using for their network. So now we are at a level of saturation that if we want to move beyond for these edge data centers, actual beneficiary to be my end customer is one of the very big opportunity for us to leverage our strength of working, providing and using data centers for a common use. This is the perspective, sir.
Thanks, Vivek. I think one live use case that we can all see today for Edge is the India versus England match, which is going to start in some time. And if you log into your Disney Hotstar, it shows on the top right how many users are connected. And at the point of times, it goes to 10 crores, 12 crores people. Almost 10% of India's population is using that to watch the match live. And that you need good latency, right? Low latency there so that it doesn't hang up all the times. And that's where there is a concept of content delivery networks, right? That maybe that whatever data that's coming in is getting reside at multiple places, because if the entire data is residing in top 4 cities and all the network is going, all 10 crore users are logging into those 4 different cities data center and getting the data, I think that could create real latency issues. So the content delivery networks, which helps processing of the decentralized networks, also evolves, right? And maybe a question to open to here to panelists who would like to take it up on the CDN side, right? That what is the impact on the CDN play, right? Players like the CDN providers, for them also with more and more edge coming in, what is the strategy from a content delivery network that kind of changes, right? And the adaptations that they need to make on the delivery of the content.
I'll just put in for one line. Everyone wants to jump in. Just one. For the CDN, I'll just give you one number. 4 years back, we had only 10 locations in India which are providing the CDN content through this age. Today we have 175 locations in India where all the content is within the districts and provided to all its customers.
So next could be yours.
I was going to jump in with a use case. So I think cricket is pretty popular, yeah? And there's a pretty big match going on today. And there was one use case which we did together with Airtel, which was Kapil Dev. You know him? I think 1983, exactly. 1983, the Zimbabwe match. So that match was recreated using edge computing and 5G. So basically, he came to the stadium as an avatar, so as a hologram, using edge computing. So you could, come real close to him, his hologram. And why this is quite cool is it's starting to show, how we can use, 3D in a much bigger way. And one statistic is how you look at video. How is video being consumed? You talked about how many people are watching, the match, right? So do you think video consumption is going up in the world? It should be, right? Yes, it should. But actually, if you look at single stream video, it's actually going down. The growth is going down. It's minus 55% this year, because multi-stream video, where you see multiple parts of the same game or person is going up. And you can download from Ericsson.com, you can download a consumer report which shows exactly this, so you can get a lot more statistics. And we're showing it in the booth, actually, where we've got 40 cameras showing different angles of the same. You can bat yourself. You can go there and bat the cricket, and you can get 40 shots of yourself at the same time. So this multi-stream video is really going to put a lot of pressure on CDNs and on edge computing, because multi-stream video, and YouTube launched it now, is just taking off like crazy. And that's only the first step, because then you get the whole VR experience, which is going to show you, much more. So CDN and edge is really going to change with this.
I was actually going to jump in and say, I know a lot of the times we're looking at video and computer vision at the edge. There's a lot more sensors at the edge that you can create situational awareness. So if you think about it, computer vision is great. A lot of this generating a bunch of video, but as you take this conference, right? So you can actually take both computer vision, infrared, all types of sensors, and reproduce all of us together. So we're actually, this is at Intel, we're partnering with Microsoft, as you can imagine, and drawing out a global map of all the users. Call it a three-dimensional view. So you can visualize today, and I'm getting into the beyond aspect of edge, right? So, and take everybody's presence and being able to map individuals globally on a global footprint. It doesn't have to be camera-based, right? So I think the situational awareness in that case becomes massive. When you start talking about smart cities, in India has the most deployed smart cities. City of Hyderabad with, hundreds of thousands of cameras. But beyond cameras are the sensors. And when we talk about these near edges, edge nodes, about 12,000 of them, just in the city of Hyderabad, right? And it's doing traffic management, the red light signals, it's doing, surveillance for police, it's doing multiple services. And, we're partnering as Intel with a lot of folks implementing that smart cities. But 25 cities in India is the most deployed smart cities. But it's a combination of CDN, it's a combination of video feeds, it's a combination of, one aspect is fun, but one aspect is control, and policing and that. And the same partner of us implemented this full streaming, it's I think multi-streaming, but beyond an event for all awareness. So the same partner of ours implemented this for the Kumbh Mela, with 250 million people converging there, where they're doing traffic management and all of that, right? So the scale in India is significantly bigger, but multi-streaming beyond just video feeds, completely sensor-based and all kinds of sensors, so multimodality, when you think about audio, visual, temperature, all of that, which is the combination. So that's the beyond aspect. As you go beyond that, being able to traffic manage 250 million people in a Kumbh Mela is not easy. But streamlining, they got a lot of efficiencies. So they're using the same bandwidth beyond the video aspect. And I bring it back to the CDN because now the CDN POPs have gone beyond content distribution to intelligence and compute, right? So I think that's the power of, you have a footprint, how much can you reuse that footprint for the multi-modality?
Got it. Thanks, Muneb. Thanks, Ludwig, on this. And I think one of the important elements that you touch is the security, right? Security of data at the edge. Traditionally, if the data is stored in a single or centralized place, the assumption is that the data will be, it'll be easier to manage the security of the data. But now if the data is getting stored at edge and the infrastructure is so spread out, there is this concerns around data security. So the next question, and with so much of cyber attacks, we have seen bigger organizations also getting impacted through cyber attacks. There's naturally a concern that how do we manage the security of data? How do we manage the, the device updates, all of those, hardware level upgrades that will need to happen with so many devices residing at edge centers. So Saurabh, over to you. Saurabh is a director at Dell and CTO at Dell. Saurabh, if you could give us some perspective, and Dell provides a lot of that infra, right, for edge. or for data centers in terms of servers, storage, and a lot of that security also needs to come at maybe some security at infra level and maybe some security at non-infra level. So, what's Dell's position? How are you, ensuring, and what do you see as a concern, the security at edge from an infra perspective, and how is Dell really addressing that concern?
Hey, thanks, Alec. So I think before we go on to the security part, let's look at the sheer volume of data that is being generated, that we generate as humanity. So every year we generate approximately 200 zettabytes of data, okay? And the edge is poised to essentially generate half of that. So that's around 100 zettabyte of data. Now, how do you backhaul all of that? Obviously, that's not possible. How do you back up all of that? Obviously, that is not possible either. And every time we swipe our credit cards, every time we do a transaction on phone, every time we try to access an access restricted office, that's data being generated right there. Or every time our faces show up on the DigiYatra app, right? So that's data being generated right there. So the first aspect is generating with this incredible quantum of data, okay? The second aspect is the sheer geographical diversity in India, right? You've got plateaus, you've got plains, you've got the highest mountain peaks, okay? You've got islands, so on and so forth. And you've got, most of all, the incredible number of people, I mean, the population itself. So the most important aspect is the ability to process data before it becomes stale, right? Data loses value exponentially as its processing gets delayed. So first of all, you need to process it right there and then. And that is where we are working on solutions which enable extremely high-powered system to run without any climate control at all. Okay, very rugged systems. The second aspect is, from an India point of view, if you see the Ericsson mobility report or the Nokia mobility report that comes in, India has the highest number of quantum of downloads on mobile connections on the planet. And we've got the cheapest mobile broadband data, and we've got the most expensive spectrum. So while 5G is there, you can backhaul some amount of information. How do you backhaul all of it? So for that, you need edge. You need to be able to process data where it is being generated. And in addition to that, you need to backhaul only the insights of the metadata, right? There's no point in backhauling everything because it will just completely overwhelm your networks, right? And then based upon that, the security aspect, as Alec, you asked, the security aspect comes into play because as you add more and more edge devices, you've got a threat vector which increases exponentially in surface area. You've got billions of devices which are connected, and those billions of devices, some of them could be used to launch a DDoS attack, right? And that's a incredibly powerful army of devices that could completely overwhelm even the best networks. And that's what we've seen, networks of federal governments being overwhelmed, networks of multiple, multi-billion organizations being overwhelmed, their websites being torn down. So all of that needs to happen through, all of that needs to be safeguarded through having synchronized updates, as you mentioned, okay? We update Android devices and Apple devices every quarter, if I remember correctly. Apple keeps on releasing their updates every few weeks, every month or so, okay? And then we've got mobile applications, right? So those keep on getting updated every week. You see a new version of Netflix, or you see a new version of Dropbox or Microsoft Office every couple of weeks. So what is essentially happening? You're basically securing the application because nothing is 100% secure. And for that, you need to have cryptographically encrypted updates, which is what we offer on our solutions, okay, which are available from a data center point of view for managing the entire data center, as well as each and every discrete edge device. Thank you.
I'm gonna add to, hey, Saurabh, absolutely right. The attack surface at the edge is massive. Like usually you could have, in a data center or cloud, massive firewalls where you can secure it. Here it's completely open. And we're partnering Intel and Dell in doing what we would say is secure device onboarding, which is fundamentally, a lot of the times you come down to where's the root of trust? Because everything needs to be validated through a root of trust. And the partnership with Dell and Intel here is really we're putting the root of trust at the silicon. So the fundamental notion is you will have application developers write applications in the data center or cloud. You're not going to be having developers writing at the edge. It's written there. What becomes a challenge is how do you establish a secure software supply chain from the data center or the cloud to the edge? If it's always running in the data center and cloud, you don't have a security issue. Like you have a security issue, but you're protecting yourselves with firewalls, etc. Once this gets pushed out, the secure software supply chain is attesting every part of the infrastructure, leaves the cloud, the data center, going through a telco network to the edge device and the near POP to the device itself. Every point, attestation of the application, attestation and securing this, because every point is a point of vulnerability at the edge. So as we do the partnership with Dell and Intel, we actually do this attestation right at the factory level. So if you followed the FIDO Alliance, which is a alliance for security at the edge, so we had done secure device onboarding, but now we've evolved that into, so right at manufacturing of every Dell hardware and the silicon, there's a certificate that goes in, and there's matching as these roll out with the zero trust parameters. Even though at the edge, you may not have an IT person, when it arrives, those tokens are passed through from the factory all the way when it's deployed with zero touch provisioning, because you have no IT people, right? So that amount of effort, both, again, Intel and Dell is probably the first to deploy FDO at scale at the edge. And if you don't get to that, you get pretty, compromised devices and nodes.
Maybe if I, no, go.
So just one thing, I think in addition to the security at the physical layer, at the chips layer as well, you need security at the application platform layer as well, because actually all the access and everything which has happened to the software platform application. So at Red Hat, we make sure, because we are based on open source things, so that we bring best of the innovation from the open source communities. And we make sure that we make it enterprise grade, because the kind of vulnerabilities, you'll be surprised if I tell you the number of vulnerabilities we kind of solve, security vulnerabilities from the open source project we solve to make it enterprise, like 2,000, 3,000, software threats, which we resolve at our platform, right? So that's the power of open source there. And one very important thing we all need to understand, that edge is all distributed data center. It's good to have secure platforms, secure infrastructure, but if at all there is a threat which needs to be mitigated, you should have ways and means of deploying the mitigation from a central location and all at the same time. That's where the role of orchestration or the automation comes into picture. So we do have an Ansible automation platform, which is amazing orchestration from the central location, you can push the security policy to all those distributed data centers simultaneously. So that's another thing which is very important. I think there's just automation of the security mitigation, at the same time making sure the platforms are secure. Thank you.
Great, thanks, Piyush. Ludwig, you want to say something?
Yeah, I was just going to bring back security to the consumer. So we talked about slicing. Slicing is an amazing way to create a secure part of the network, and the ambulance example is one which really brings that, to its fruition. But there's one problem with it, and the problem is that we're talking about standard slicing. Standard slicing means that you give a priority to one user, in this case the ambulance, right? But what's really cool is a new abbreviation. I don't know if you know URSP. Have you heard of URSP? It's a UE route selection policy. And why is this abbreviation pretty cool? Because it allows you to have multiple slices on the same device. So you can have different security settings, of course, for these different ones. But it also allows, so that means that if you push one of the applications on your phone, if you push Teams or Zoom video, for example, you could set up a slice for that. So there's multiple slices to the same phone. And why is that super cool? Because you and I, we don't want to pay more money for our subscription every month, but still, we want to have better and better services. So by having this, it allows our customers to have an additional revenue stream, which doesn't have to come from the consumer. It could be, Zoom or Microsoft that's actually paying for that slice to be set up for their service to be pretty good, like a cricket match, or like the Zoom video, or the ambulance example. So with URSP, which is available now from iOS 17 and Android 12 and 13, it really allows for the possibility for edge computing to flourish, for security to be for individual use cases, and for more revenue to come into the players in this industry. So pretty cool.
Thanks, Ludwig. So I think with all infra level, platform level, software level security, it's safe to assume that the security at edge is pretty much taken care of. Okay, so we are almost at the edge of time. I'd like to open it to the entire hall here, to participants in the session room. If you have any questions, you can just raise your hands. We'll have someone pass on the mic, and you can address the question. You can either it can be the question to the entire panel, or if you have any specific question to any specific individual, you can mention it and then mention a question.
Yeah. Okay. The question specific could be to the Airtel or the Ericsson. Sorry, I'm not using your names. But what I wanted to start off was, from a Linux point of view, you talked about the open source at the application level of security. What you covered at the Dell was keep having refresh and keep having those latest updates which are coming out from the security point of view. And at the chip level, we are talking about some security which was mentioning. You talked about network slicing, some kind of protection, and that better route which is there. My concern, which I would like to just clarify, is we are talking at the edge. And at edge, it's going to be totally wireless. And at wireless level, we are going to have miniaturized things with lesser power and try to depend on one base station or two base stations or three. This is my thinking on this particular issue. So what happens if that particular RF level interferences are there? So all the edges are going to be out, and it's going to be a major security issue when so many devices are out of any connection. So not exactly the security from content point of view, the security from a RF point of view, where you may have all your edges, the devices, going out of the connectivity. That's the question.
Maybe I could start if you want to add later, Vidya. So first, 5G is the most secure of all of the Gs, which is pretty good. But you're right, there's more devices, there's more interference levels, and really, just like your phone is updating the applications. You don't know what version of WhatsApp you're using, you don't know what version of Teams and so on you're using. It's really important from a security level, even though the technology is secure, you need to ensure that the applications that are running on the network, both the network, the CNFs, but yeah.
Talking about the RF interference, which is going to make your device non-functional.
Yeah, no, exactly.
That's the question which I'm putting.
Yeah, no, exactly. So therefore, it's really important that the network, not the applications on the phone, but the network also does continuous updates, just like the phone does. And there is another abbreviation, which is ISSU, so in-service software upgrade. So the network needs to be continuously updated, which is what this technology provides.
So let me take a stab at answering your question, okay? So first of all, from a 5G point of view, what increases is your spectrum, right? So you've got significantly more spectrum. Let's say, for example, on the millimeter wave, you've got 1,000 megahertz. On FR1, which is below the mid-band, you've got around 100 megahertz. If you remember, in 2G, we used to have
The edge device cannot have all the spectrums. Edge device will be at a particular
Would you
place.
please let me answer the question, sir? Okay. So first of all, from a technology point of view, you've got bigger bands. Okay. Then you're using incredibly higher order modulation and encryption, okay, to push the updates. You've got AES 256-bit, you're moving on to AES 512, so on and so forth. So your encryption is also increasing. And why is your encryption increasing? Because every time you increase the encryption, you need more math, right? And that is where our friends from Intel are building in solutions which consume lesser power on the battery, okay, so that it can run for a longer period of time, okay. In addition to that, you mentioned interference. Because you've got so much more spectrum, you might not need to use the entire band, okay. For example, in NB-IoT, you use a much smaller part of the band, but because you've got a massive swath of spectrum, you can, essentially push devices on different frequencies within the band or different codes within the band, right? So that is how you mitigate the interference piece. Then on 5G, again, okay, for devices which actually do need significantly higher bandwidths and are tethered, okay, or because look, edge devices could be nomadic, edge devices could be fully mobile. Edge devices which are fully mobile will obviously have a power source commensurate to their mobility options. Nomadic devices will obviously be plugged in most of the time, and stationary devices will always be plugged in either to something like a solar-powered generator or DC or whatever, right? So those devices will have the ability, the compute, the resources to sustain that communication, okay? And that is what is essentially, perhaps trying to answer your question, okay, that is what is built into the technology. And in addition to that, what Ludwig also said, so when you look at network slicing, one slice is completely isolated from the other slice, okay? You cannot even ping, so there is no reachability unless you create it so, okay? So that is where, even though, let's say, you and I are doing some activities on the same band, on the same spectrum, on the same, in the same location, we're completely isolated. There is no way that I can hack into your slice. Does that answer your question, sir, or would you like me to? Thank you, sir.
Any other questions, please? Okay, if last call out, guys, any other questions? Otherwise, then we can call it a session. Great. Thanks in that case. I think it was a great interaction. We started more from the understanding what is edge, the business potential of edge, the business elements of what's going to drive edge, and then we moved at elements around security, around efficiency at the edge. I think it was a great discussion. Thank you so much, to all the panelists. It was a pleasure listening to all of you and especially hearing both on business, especially a lot of technical elements which are new for me as well. I hope I hope you liked the session. I hope it was useful to, to whatever extent to all of you. And thank you for joining in. Thank you very much.
Thank you. Thank you so much.